In this video, we're going to learn how to factor by using the difference of squares. So the difference of squares factoring strategy is a factoring strategy that can be used in very specific circumstances like we see here on the left-hand side. So what you'll notice there is we have values of a and b, and those just represent a term. And essentially what we're looking for is that the term that contains a is whatever that a value is squared, and then the term that contains b is whatever that b value is squared. Now, most of the time this is easier to see in an example. So say, for example, we had something like 4x squared minus 9. So what we're looking for here is we're looking to see if this term here is represented by some a value squared. So what I like to do is go off to the side and do the square root of 4x squared. Well, I know that the square root of 4 is 2, and I know that the square root of a squared is just x. So really what's happening here is I have the term 2x being squared. Then from here, if I look at this next term here, I have a 9. And if I square root 9, I get 3. So what I really have here is my a squared, which is 2x squared, and my b squared, which is 3 squared. So in this case, a can be represented by 2x and b can be represented by 3. So when we're going to use the difference of squares factoring strategy is we're looking for this type of situation where you can break this down into an a value squared minus, hence the word difference here, a b value squared. So if we see that we have something that can be broken down into, as we can see here, 2x quantity squared minus 3 squared, we can then follow this pattern here in order to factor it. So here we can see that a is equal to 2x and b is equal to 3. So because I have a difference of squares situation, I can follow this pattern here. So I'm going to follow that pattern, and remember it's going to be a minus b times a plus b. So if I use the values for this particular problem, I'm going to get a is 2x minus b is 3 times a is 2x plus b is 3. So I can use the difference of squares strategy to end up with my factored form of 2x minus 3 times 2x plus 3. So now let's see if we can use this difference of squares strategy on another problem. Now, using the difference of squares strategy is typically the easiest if you know your perfect squares, at least from 1 to 12 to start. Beyond that, we can use our calculators to check. So you should know 1 squared is 1, 2 squared is 4, 3 squared is 9, and if we keep going, we have 16, 25, 36, 49, 64, 81, 100, 121, and 144. So you should know those perfect square values. Now what I like to do first when utilizing the difference of squares strategy is first I look for a difference. So here I notice that we have a subtraction, so it's got the difference part of the difference of squares. And then I look at each term one at a time. I can see here that 36 is in fact a perfect square. That would give me 6. And I see that the x squared is squared there. So if I take 6x and have it represent my a value, I can rewrite 36x squared as 6x in parentheses squared. Then if I look at 49, I notice that that is also a perfect square. The square root of 49 is 7. So I can rewrite this as 7 squared. So I have an a value equal to 6x and a b value equal to 7. So I can factor 36x squared minus 49 by taking my a value of 6x and my b value of 7. So if I follow the strategy I learned on the previous slide, I'm going to follow that pattern of a minus b times a plus b, which in this case becomes 6x minus 7 times 6x plus 7. So here I have my factored form using my difference of squares strategy. So if I look here at example 2, what I notice is that 162 and 242 don't appear to be perfect squares. However, What we also have to remember as we're utilizing all these different factoring strategies is that sometimes we have to factor out that GCF first. So if you forgot from previous lessons, we always want to look for a greatest common factor. And what I notice here is that both of these are in fact divisible by 2. So if I factor out a greatest common factor of 2, I'm left with 81x squared minus 121y squared. And now what I notice is that both 81 and 121 are perfect squares. And because I have the subtraction in the middle, I know that I possibly have a situation where I have the difference of squares. So we know that when we utilize the difference of squares, we ultimately end up with 2 parentheses with values on the inside. So let's take some time to figure out what that's going to look like. Well, remember I need to figure out what squared is giving me 81x squared. Well, the square root of 81 is 9, and the square root of x squared is x. So this is really represented by 9x squared. Then from here, we end up with 121, and we square root that, which is 11. And then if I square root y squared, I get y. So what I really have here is 9x all squared minus 11y all squared. So my a value here is equal to 9x. My b value here is equal to 11y. I've proved that I have a case of the difference of squares. So if I substitute in those values, I get 9x minus 11y and 9x plus 11y.